Welcome to HttpClient requires an anti-pattern for performance. Hey, I'm Eric, and believe it or not, this is the third time I have tried to record this video, so I truly hope that this one is the one. And there's stuff I'm not going to do in this video because I don't have the equipment to successfully do what I wanted to do and record a video at the same time. So some stuff I'm just going to explain to you. Anyway, the topic for today's video is the HTTP client. That's the data type that is responsible for talking to web services and handling all the actual movement of data back and forth during a HTTP call. Let me show you what I'm talking about. So here is a small test function, HTTP test. And you can see that it starts by a client.get. We have an address that we want to get. This is just the inside the Docker image. There's an extra little web server on port 8080 that serves out the Visual Studio language file for that specific version of PC that runs in the Docker. So we're using that in order not to annoy other places. Anyway, so the second parameter to client.get, so client is the HTTP client. The second parameter is an HTTP response message, so that's what we're getting back. And we're testing if we're getting a successful status code back, and then we're reading that out to text and show it on screen. And I can compile and deploy this. And let me try it out. So I go here and I go action, HTTP client test. I get the HTML behind this very small page. So that works quite well. And that's how, if we look at this code, this function, we can see, oh, there's perhaps a bit of error handling missing that we probably should add. So the first thing is that get actually returns a Boolean. So if it's okay or not, but if we go and ask Business Central HTTP client the documentation, we can see that if we do get, for instance, and it's the same with send and with put and post. So return type, accessing the HTTP content property of the message in case when the request fails will result in error. If you omit this optional return value and the operation does not execute successfully, a runtime error will occur. So it's saying that, okay, if this one returns false, you cannot access the response message because that's not valid at this point. So the only thing that if this function returns false, then the call failed completely. It failed to execute the call at all. So it was not like that it connected to the server and then something happened. No, it just failed. So we clearly need to handle that. So if client get, then let's actually put a begin here. And then let's extend our that's hard to say tonight, HTTP test to return a Boolean. So in case of, let's say that we have seen the message, so that's clearly an okay, that's true, but we really don't actually want to do this. So if we say that here, I think this is good. Let's just save. So now we say that if HTTP client.get is just able to make the call, then we're good. Otherwise, we're bad. And so this is what I did in the other videos. I said, okay, I got to this point. I created a variable here. And then I said, okay, for I equal 1 to 50,000, random number, not really random, but up there. Then if not HTTP test, so if this fails, then error saying failed after calls. So otherwise we'll do a message success. Wow, how many S's? I don't know. And then I ran this while recording a video, and let me find the screenshot of what happened. Here is, let me, oh, let's see if I'm able to make this big enough. So you see, this is actually a screen capture from a video, and my head is looking down, so you're looking at my forehead. So you can see that failed after 28,479 calls. At that point, client.get stopped working, and then a few minutes later, less than a few minutes later, the machine stopped working. And by machine, I mean actually my PC, but that's because I'm running this in a Docker that is in processes. So it's not, the Docker image is not saved running as a virtual machine. It's in process, whatever the definition is. So it's actually just running as processes along all the other stuff that's running on my machine. And boom, everything went to pieces at that point. And this is an error that we encountered with the Cloud Replicator. So the Cloud Replicator is an app, new app we just did, that is moving data from BC to a cloud database, moving that at as fast as possible. So we're spawning up multiple sessions and doing lots of stuff to move data as quickly as possible out of BC into a cloud database, so people can do reporting on that. And in some cases, we had these strange errors. Suddenly, HTTP client stopped working, and you know, this is, if you think about if this were records that we're copying, and this is the copy function, that this is what we did. And very strange. And then I was pulling long hours, and suddenly it dawned on me that HTTP client is of course just the .NET version of the data type in .NET called HTTP, called HTTP client, and that one is special, and that one is not as it should be, and not as it reacts differently than what you would expect. So what it does, it thinks that, okay, that typically people are doing multiple calls. So it's trying to save up sockets and connections and reuse them. But what we're doing here is that we're creating a new instance of the HTTP client, we're using it, and then we are exiting out and disposing it again. But it's not really disposing, though. The danger here is that we cannot control iDisposable in .NET as normal .NET users, because we're doing .NET through AL. So what happens is that the system will simply run out of sockets, and depending on how many calls you're doing, depending on what else is happening on the machine at the time, it can happen very soon, or it never happens. So in this case, well, on my machine, I could, and if I reran the process, I could get the call, the error after just a few thousand calls. And what HTTP client is doing behind the scenes, that it's like it's having a 4-minute timeout and stuff. So if a socket is more than 4 minutes old, it's throwing it out, and so you get this very erratic behavior of network connections just stop working. But the interesting thing is that this also, apart from a reliability perspective, that you gotta have it to work, it's also actually a performance issue. So I thought that would be an interesting thing to take a look at in this video. So if we change this guy up here a bit and create a variable for holding a start time, and then we do s equal time, and we'll change this one to add something in here. So we'll do time minus s, and we will not do 50. We'll just do, let's try to do 500 calls. Let's see how that goes. So let's deploy this. So what I'm doing now is that I'm timing how long it will take to do 500 calls. And time minus time just returns not a duration. That would be too easy. So in this case, it will just return an integer of milliseconds. So let's kill the other tabs and try this out. See what we get. 1.48 seconds. That's not bad, 500 calls. But let's try to do one simple thing here. Let's try to move this guy out. So now it's a global variable within the same object, right? So we're still in an object. And let's try to do this again. We'll run it. And come on, BC. Do this again. Oops, 800. Maybe we should try this on a largest number set. So that one was slower. Or not slower than. There's a fast one again. Let's actually, just for proving my point, let's up this to 1500. We'll go back and then we'll do here HTTP. What did I call it? Client. And then we need to get rid of this guy. So this one should override the other one, but in case of variables with the same name, that's just bad practice, bad code, and that's not the anti-pattern we're looking for here. We're looking for the fact that we need to use the global variable. So let's try this one. This should 5 seconds. Let's see how it goes. 3.7 seconds. Let's do a couple of runs just to be sure. 4 seconds. 4.3. I think that's enough for a little more testing. So let's get this one back and let's get rid of this one. Do this again. Come on, BZ. Let's get rid of the old sessions here. See what we get. 3. That's very constant this time. Interesting. To 9. Interesting. With a larger number of calls, it seems to be less as good as it were with the fewer calls. So what we observed with the client replicator was that this would have a lot of impact. I don't know if it's different when we're in the local machine. That might be the difference between making a local connection and a connection to somewhere else. We can let's try to do something like that. Let's just do 100 calls to begin with. So now let's try with the local one first. See if this is working or not. So what at some point we almost saw a factor of 2 in the raw time spent on that piece of the connection. It doubled. See what we get here. So I never got this far in the other videos because I did the 30,000 run and then it just fell. So 15 seconds for 100 calls to Google on a local variable. Let's try with the global. Deploying again. And while we wait for this result, how about remember to subscribe to the channel and let me know in the comments below. Oops. See, that is actually pretty close to what I said before. So 7 seconds instead of 15. Let's do this again. Anyway, I was just going to say, let me know in the comments below what you use HttpClient for, and if you're putting it into loops like I used to do. I'm not doing anymore. I'm using global variables from now on with this guy, because you can see here, and when actually making connections outside the machine and not just internal machine, it's a massive improvement in performance from 15 to 7 seconds. Anyway, before I break any more stuff, I'm gonna end this video so there's something to upload in a bit. I hope that you enjoyed this, and if you ever had frustrations with HttpClient, it might be the same issue as I had. Otherwise, I suggest looking at your code and see if you can get the improvement, speed and performance improvement that I did here just by changing it from a local to a global variable. Anyway, that's it for this video. Have fun, and I'll see you guys in the next one. Take care. Bye.